Hello everyone and welcome back to another Universe Sandbox 2 video, and today we're actually going to turn in Eris into a star. So if you remember last episode we did Charlico and you guys seem to have liked that. So yeah, someone said to do Eris and I'm like, hang on, I've never done this one. I'm surprised I haven't, because this is like the second main dwarf planet after Pluto. So yeah, I'm pretty surprised I never picked up on doing this one. So yeah, we're going to be doing this today. But yeah, before we get started guys, just many thanks as always. We're now at 1,220 subscribers as of making this. So yeah, let's keep up the good work and let's see if we can keep going to 1,300 before the end of the month, because that'd be cool. But anyways, let's get into this. So what I'm gonna want to do here is let's do it a different way for a change. Instead of just colliding it with stuff, let's just manually make it bigger, because we don't really do this much. So let's just make it bigger. So now Eris is pretty much, yeah, this is large enough to be a planet now. So let's keep going. So we're gonna get a nice large Eris. So yeah, this is my custom one as well. So if you want a good look at it, I made it nice and white, so it's like a frozen sort of look. I like it. So yeah, there we go. Anyways, let's speed this up and let's keep going. So yeah, it's quite a unique way of doing it because I've not done it like this in a while. So let's go. So yeah, anyways, looking good. So, and also guys, coloured solar system episode will probably be coming out tomorrow. So yeah, tell me what colour should I do. So we've got 4 left now, I think. So it's brown, white, grey, and I think they'll ground, is it grey, white, brown, and is that it, or is there more colours? I think it's just those two ones, and then pink as well. Yeah, pink. So yeah, pink, white, brown, or grey. Which colour should I do? And if you've got any more colours, feel free to comment them down as well, because that's cool. Because yeah, if you want the series to keep going, I need more colours to do. So yeah, that's how. Yeah, but probably expect a coloured solar system episode tomorrow. So yeah, stay tuned for that and tell me what colour you want. Anyways, let's keep going here. So now we're the size of or yeah, about double the size of what Earth is now here. So this is good, and let's keep going. I'm getting a lot bigger now. So now we're at the size of almost Planet 9 here. So this guy's getting pretty big here. So quick comparison with the planets here. This guy is just a little smaller than Planet 9 now, so a lot larger than Earth. So it's giant rocky planet now, no longer a dwarf planet. So let's keep going. Let's make it even bigger. So let's get going. All right, come on, let's go. 60 Earths is really increasing fast now, so let's keep going. Let's see what it is in Jupiter's here. So there we go, it's half the mass of Jupiter, and it's still going now. Now we've got to the mass of 1 Jupiter now, and then getting bigger and bigger. So now we're exceeding the size of Jupiter here. So this is a pretty large object now. Let's keep going. Let's make it the size of like, what stars should we base it off today? So we're not going to base it off one of the hyperstars. Let's base it off maybe Spicer. Oh, let's use this one, this Archinar, because I have never ever used this star, I don't think, in a simulation, so let's get some use of that. So we need to make this thing the mass of 6 suns, so let's keep going. So let's do this, and let's go. So, the mass of 6 suns. So now it's a gas giant, as you can see, it's just got so big it's now just gas, even though it's elements here, it's only made of iron and silicate, but yeah, I don't know that logic there. Quite a nice blue and white looking object here. It's looking good actually, maybe I'll... should I keep it? Nah, it's not really anything special. So yeah, let's keep going. And then as we heat it up more and more, it's probably going to start turning into a brown dwarf. So if we speed up time here, you can see in its temperature, yeah, this is going to start heating up. So, okay, a little faster. Is that enough? You going? There we go. So now it's a brown dwarf star. So it's starting to, yeah, it's really heating up now. So it's going to continue making it larger until it pops into a star pretty much. So let's do this. Okay, come on. Oh, and there we go. So now it's a star. And now let's increase the mass. So we need to make it 6.7 suns. So yeah, this is quite a nice unique one. So let's keep going here. So it's now the mass of only 0.1 suns. This might take a while. So let's just put it up to 5 suns. Let's keep making it a little bigger. And do we need to put realistic mode on? I don't know, because it doesn't seem to be doing it. So how large is this star? This star is... okay, that's 5. I think that's 500,000 size. 70,000. So that's 500,000. So let's just do that. Let's just put it straight to 500,000. So 500 and then 1, 2, 3 like that. So now it's nice and big. And then let's put it to a mass of about 6.7 suns. So it's a little bit further. So 6.7 or 6.69. So there we go. So now we've got a very big planet out here, or not planet, star I should say. And how luminous is this? So I'm gonna have to quickly check by putting it just out of the solar system, just completely out of the way here. So this star has is 2,858 suns. So let's go and do that. So Eris, let's go to, what's it 2,558 or 58 or 57, something like that. So there we go. Unless I'm going bonkers and I just marked up. Wait, let me check that again. I'm sorry, guys. I'm just awful. So this is okay. 2,858. Yeah. Okay, 2,858. So it's 2,858. There we go. That's what we want. So now let's also make it a blue star, since that star was a blue star. So let's just add a 0 onto the end here. There we go. 500,000. So there we go. So there's our Eris, and it's looking pretty monstrous with that blue star with that red fire coming out. It's pretty cool actually. So that's the star it's based on there. So it's a little small actually. Should make it a little bigger. If I put an extra 0 on the end. Yeah, that's how big it should be. I must have messed the number out. So there we go. Now we're going to start seeing what havoc this star's going to cause. Because as you can see, it's already ruined some of the orbits here. So now we're going to hit play. And we're going to start seeing what stuff unfolds. So we're going to go to Hermea here, because this looks like it's going to get the first piece of action. So if we just look down, oh, it's getting a bright glow from that star. So look at that. Looking good. And it's why is it a yellow glow? It should be a different colour glow. Let me fix that quick. So let's just save and reopen this simulation just so we can get the correct colour. So where is it? Where is it? There it is. So we're going to reopen this. That's what it should look like. So it's a blue star. It should be lit in like blue sort of coloured light. So there we go. That's what we want. So now if we just check orbits again. Yeah, everything's the same way as it was before. So we hit play, and now stuff is going to go down. So what is up with this Planet 9 orbit? Oh no, that's not Planet 9. No, I'm sorry. That's the Eris. Oh, I thought that was Planet 9. No, that's Eris. What am I saying? So let's speed this up and let's get this going. So yeah, let's get this party going. So we're going to start looking at. I want to look on Venus and Earth first. So Earth is increased in temperature. That's not good. And Venus is getting a little too hot now. As you can see, its atmosphere is starting to disappear by this. So yeah, it's got 2 suns now, and that is looking good. So let's just put it on just stars, just so we can see everything easier. So there it is. So where is this star in the night sky? Can we see it? Well, surely we can. Yeah, there it is. So quite large. Not as large as the sun is, but still a relatively large star from the distance or from where Venus is. It's only a little smaller than the sun, it looks like, honestly. So yeah, this is going to get interesting. So let's check up on Earth now. And maybe Mars will become habitable. We never know. So let's keep an eye on. And actually, just put the habitable zone. So let's see what the zones are. So okay, does this even have a zone? Or are we just too... Okay, this star doesn't have a zone apparently, so that could be a little menacing. So let's zoom in here. So what planet is this? This is Earth. Look at this, that blue light on this side. And then we've got the sun. So it looks brighter on this side than it does on that side, but maybe just be the game. So it looks like there's a shadow here, even though there shouldn't be. So I don't know what that's all about. Anyways, yeah, Earth is at 67 degrees now. So yeah, us humans probably not doing pretty well right now due to this hot temperature. So climate mode would be off because there would not be any poles anymore. So as you can see, Earth's looking pretty burnt up as there's no green sort of grass. It's all dry. And as we can see, the oceans are cooling because if we look here, there is no longer any British Channel in between the United Kingdom and Europe here. So that's all one continent. Italy in this area here, that's starting to dry up. And I'm pretty sure that gap between Spain and Portugal and Africa, that's going to close as well into the Mediterranean Sea. We've also got the Gulf of Mexico's closing up, making new land for like Florida and bits of Mexico and these states here, which I cannot remember, so I'm sorry if anyone's from there. Australia as well is connected with New Guinea now. I can never pronounce that one. Looks like these islands are connected with. Is that what country is that? That's not China. No, China's there. So I don't know what countries those are. South Asia. I'll just call it South Asia. So that area there is now connected with this, and that's going to connect with Australia soon. The Saudi Arabia is connected with Asia now, and the Mediterranean Sea is pretty much dead now. So that's not good. And then USA and Russia are connected up here. Let's just keep going. Let's see how hot it gets. So 84 degrees. Is it going to stop there? Or is it going to keep going? So doesn't look like it. The Mediterranean Sea is still open, as you can see here. A very, very small gap. So if you landed on the surface here, yeah, you could probably see Spain from Africa now because they're just so close. So that is not good. Actually, even without any burned up oceans or anything, you probably could see Africa from that part of Spain or Portugal. And that's Spain. Portugal's a little further to the left there, so that's pretty interesting. So let's keep going here. Now pause. Is it closed up yet? No, it's still going, but yeah, bits of Mediterranean gone. This lake here is disconnected from the ocean, it looks like. There's a few more bits of water in there, but Madagascar's gained some extra land, and the Maldives actually are probably doing pretty well as well. They're this is the Maldives, isn't it? Well, there's a lot more islands now, it looks like. Look at this. Yeah, I think they're the Maldives. Whoa, the heck. Let's zoom in again, okay, so let's keep going. So is it going to dry up? Or no, it's stuck at 80 degrees. So even though the land hasn't fully dried up, or the water I should say, we probably could manage to hit this to live here, but I don't know. That put the green back on, but yeah, that's probably going to do much. Well, if we put climate mode on, it seems to heat up more, so we just turn that off. We'll put it back to what it should be. So maybe we could live here. I don't know. Could we live at 84 degrees? It'd be very, very hot. But if we had like air conditioning, maybe it'd be fine. I don't know. Yeah, what do you guys think? Could we live at 85 degrees with our current technology? I'm pretty sure we probably could. But honestly, right, places like Africa, Spain, this like north of South America and then south of North America here, Mexico, probably the Caribbean here, Australia as well. That's a hot place, and then all of these islands here, the Maldives, India. They must be really hot because that's the equator of Earth. So yeah, if it's got an equator, then it's got two suns. That's probably going to be good. But it's probably this side that's hotter than the normal side. The side from the sun, this is probably the colder part of Earth. But when it goes into the light of Eris, that's probably the brighter part. Anyways, enough of me talking about Earth and its constants and stuff. Anyways, let's go back to Venus. How are you doing? So Venus is glowing hot now, still at 500 degrees. Okay, Mercury, how are you doing? So let's check out this one. Okay, Mercury's still doing pretty normal, 140 degrees. That's not really changed. Mars, how's Mars doing? Let's check out Mars. 31 degrees, so we could live here. It's warm enough. That's how much Earth would normally be on a hot day. So yeah, that's looking good. So we could probably colonize Mars with this temperature. That'd be our new home in this solar system, as long as the sun doesn't explode or anything, which probably could happen. So let's keep an eye out. Let's go to Neptune. That's a good old favourite planet. So minus 54 degrees. So Neptune has warmed up more than it usually is. It's a lot brighter here now, so that's nice. We can really see that good blue. Oh, I love that blue. That colour, so nice. And then obviously not forgetting Uranus as well. My custom Uranus, custom texture on this. This is a very nice light blue as well, looking good. Yeah, but that's only minus 19 degrees. So this is meant to be the coldest planet in the solar system, but that's not true anymore. It's probably Neptune now. So they're there. Jupiter and Saturn are probably, okay, minus 12. Saturn is minus 23. So, yeah, Neptune is the coldest planet now. Oh, obviously, apart from Planet 9. But we still don't know if it exists for sure. But we leave it in the simulations anyway because it's cool. Anyways, let's see what these guys do. So the closest objects are definitely, I'm pretty sure it's Haumea. I'm sure that's the closest object. So, let's keep going here. Let's speed up for real now just so we can get a little more. So, it's only 55 degrees in this dwarf planet. So, it's probably going to start evaporating and stuff when it gets too close. So, can we run it any faster, or is it going to be really slow? Okay, no, we can run it faster, okay. So the orbits in the solar system are all changing due to this second star here. Looks like Charlotte's orbit has changed, Neptune's orbit's changing. Basically, they're being pulled away from the sun. The sun's gravity is just not strong enough anymore. But here we go, Haumea is on its death run now. So, oh, it's getting close, oh, it's burning up. Look, it's so close to Eris. Oh my god, look at that. So, yeah, it's probably not going to survive too many laps around this star because that's a pretty bright object, as we can see. Oh my god, it's like vaporizing here. So let's land on the surface here. Let's pause. That's a pretty bright star. Look how big it is. So yeah, there's the poor old little sun over there. So poor little sun. It's so small and cute. But then you got this bad boy. Look at this. So that's pretty crazy. So let's keep going here. There we are. So yeah, that'd be pretty cool to see in the sky though. But remember, I think like the pulsars, like the video the other day where I put the crab pulsar where the sun is. I believe blue stars emit a lot of dangerous radiation. So even if you were or your planet was at the correct temperature for life and it had water, there may be too much radiation for you to live there. I think I'm right on that. I'm pretty sure blue stars are very dangerous. That's why it doesn't have a habitable zone, because blue stars don't have them because they just emit loads of radiation. So yeah, I think I'm right on that. If I'm wrong, please correct me because it was interesting to see what everyone else has to say. So yeah, Haumea is losing a lot of material here, as you can see. It's smoking up, as I like to say. So yeah, it's losing a lot of material, which isn't good. So is it going to survive its pass with the star? It looks like it is. So probably it's its closest point. Look how close it is. Damn. It's very hot here. But it is cooling down, so it is escaping Eris, so it did make it out alive. But it's probably didn't survive too well from that. So what's next? Okay, maybe Make or Make, or however you want to say it, coming in next. So, is it going to be that? Or are we going to see anything else? So let's delete the particles from that so it goes. Okay. Okay, you can spray more particles as well, that works. Okay, it looks like Hamea may have been thrown out the whole system actually. Maybe it got too close to Eris, it got a giant slingshot and it's not got enough, well, it's going too fast to get around or start orbiting again. So it looks like Hamea's been completely been thrown out here, but the sun and all the planets are being pulled towards Eris here. So the inner solar system is not doing very well. As you can see, there is no ocean, so the whole Earth is just one giant continent because... Oh no, I'll tell a lie, there is some water there. Very, very small patches in where the Antarctic and sort of South America meet. So this must be very deep water here. I'm guessing the Pacific Ocean as well probably has some water left in it. So, yeah, as you can see, I think that's the Mariana Trench there, if I'm not mistaken. Is that right? Is that Mariana Trench? Some of the deepest parts of the Pacific. And this is also the Ring of Fire. If you didn't know, it's in the Pacific Ocean. There's something called the Ring of Fire, where the tectonic plates. There's like a ring of tectonic plate activity or something. I don't know for sure, but yeah, the Ring of Fire is somewhere around here. But yeah, there's this. I'm pretty sure this is the Mariana Trench. And if I'm wrong, please tell me. Yeah, I'm pretty sure that's the Mariana Trench, the deepest parts, because the deepest parts of the ocean are the last bits of ocean to disappear. So yeah, that's that. The Atlantic Ocean is completely gone. Mediterranean Ocean, South Atlantic. Indian Ocean is gone as well. There's the Maldives there. They're probably doing good now. The North Pole, there's no water there. So it's mostly water in the south sort of area. Apart from... Well, it's basically just the Mariana Trench. Oh, no, that's gone as well. So, completely uninhabitable now. There's no water there. 160 degrees. Even with air conditioning, I don't think we'll survive that one. So, Mars, 165. Venus must not be doing good. 800. So, yeah, Venus is completely uninhabitable. Mercury's still relatively cold at 286. Ceres is at 222, so it should be more reflective than that. Ceres is always bugged out. Chiron, that little dwarf planet. Saturn and Uranus are very close to each other right now, damn. So yeah, Saturn's 200 degrees, Uranus is 268. Make is getting very close to Eris there. Where's good old Neptune? Oh, Neptune's well out of here. Look, he's in the safe zone, minus 42. So yeah, Sedna, minus 139. Planet 9, minus 177. So yeah, these guys are fine. Let's just see, is Planet 9 receiving light? I'm pretty sure it probably would be. Yeah, Planet 9's getting plenty of daylight. Wait, hang on, no. Realistic mode. Yeah, Planet 9's getting daylight. Okay, that's good. Alright, next up, where is Make? So as you can see, Make's the next object on the... Oh, no, it looks like it just escaped Eris, actually. So, it looks like Uranus and Saturn are next. So, let's see how these guys are going to do. So, we're going to get closer. And the solar system's still being pulled towards Eris here, so that's not good. So Uranus and Saturn are coming at a relatively close period. So can we see them from each other? Oh, you can. Look, there's Saturn. Oh, that's Venus. Where's Saturn? Saturn? Oh, there it is. So if you look carefully, you can see glowing Saturn over there. So that's pretty cool. So it's like Uranus is getting closer than Saturn. Yeah, it is. As you can see here. Oh, that's close. We may be able to get some sort of eclipse when they both cross the star here. So will we see any eclipse? Maybe Saturn going across the star? Can we see it? Let's have a look. Well, we can see Saturn. You can clearly see it there. If we just land on or land on top of Uranus's clouds here, and we look up. So if we look up, you can see the sun over there. That's Venus, I presume. Yep. And Saturn is right there. So there you go. So looking good. Where's Uranus? We should be able to see it from Saturn. So Uranus should be down here somewhere. So yeah, where's Uranus? So Saturn. So Uranus is down there. So if we look carefully, you can see Uranus and Saturn just as well. So let's look here. Very, very bright. So let's land on the top of Saturn's clouds as well. So where is it at? Okay, there it is. So Uranus is not as visible as Saturn was, but it is there in the night sky, as you can see there. So looking good. Anyways, let's get out of the surface mode. Keep going, and those guys are fine. Yeah, they're not going to get too heavily damaged from these stars because they're large enough to lose mass. But it's the smaller objects that I'm worried about, and also supernovas. They'll take out Uranus and Neptune usually. So it's usually just... Oh, no, they only take out Uranus and Planet 9, I think. Actually, no, what am I saying? No, it's only Uranus that gets taken out of the gas giants. Uranus is the weakest gas giant against supernovas. Probably because it has less mass and stuff like that. So, oh, they're getting really close now. This is not good for the inner solar system. So, yeah, High G is smoking up. Mr. Spock. That asteroid there. Earth and Venus are probably not... Yeah, Venus is gone. Earth... Where's Earth? Earth's at 700. Even Earth's glowing hot now. Mars, glowing hot as well. But how close are these stars going to get? So here's Eris here. Jupiter's just got slingshotted away, it looks like. Oh, they are really close. It's probably going to steal. Yeah, stolen Mars. Look, Mars has been stolen. So it looks like the sun's the sun is orbiting this star as well. This star's got enough mass to hold the sun on, obviously. So looks like we've got a different conclusion from usual. The sun is actually going to orbit around the star. So instead of getting a supernova, we're actually going to get a different solution. So that's pretty cool. But there's a lot of objects which have been thrown out. Chiron, Ceres, Pallas, Vesta, they've gone. Anything else? Planet 9, Sedna, they're all doing good. Haumeia's gone as well from earlier. Yeah, they're all gone. So let's see what's going on here. So Mars, the closest planet to the star now. This is the one that's closest at all times. Unless Uranus and Saturn come back. So yeah, that does not look good. Anyways, so the sun's all the way out here now, but will Earth recover? Oh, it is! Look at that! It has recovered. I spoke too soon. Oh, no, it's back. No, it's back. So there is some life, or life probably could start again if it survived that apocalypse of 700 degrees, but Earth's looking pretty good now. So it's okay, I think, but it's still drying up. Because remember, it's still orbiting the sun, but now its orbit's really, really weird because it's got affected by the other star. It's getting a little closer to the sun than it normally should be. So yeah, Earth's going to rapidly change as well. So that's not good. As you can see, the orbits out here are still wobbling around. I don't know how Planet 9's not being thrown out, and Sedna as well. They're still very cold. Anyways, let's keep going. Let's speed the simulation up a little more just so we can get more, we can see more. So let's speed this up. Wait for the sun to return because that's what we mostly need to see. So the sun is coming back. More objects have just been tossed out. Mercury, Charlico, Ixion, that dwarf planet there. Uranus has gone, I think. Oh, is it? Yeah, I think Uranus has gone. So what's left? So let's slow down again. So we've got Mars. Mars is still surviving. Mars is very lucky, actually. It's getting roasted, but it's still surviving. The Sun and Venus are left. So there's those guys. Earth has gone, so Earth's going to cool down and just become an ice age again. So that's not good. Yeah, Uranus has gone. Good old Neptune. Yeah, he's surviving nicely because he's just far away enough from the action. Okay, the Sun. It looks like the Sun and Eris are in a binary sort of system now, which is pretty cool. Oh, Pluto. We haven't seen on Pluto much today. So how's Pluto doing? Okay, Pluto's doing relatively fine, looks like. It's out of the way. But Mars, oh, poor Mars. Well, it really is a red glowing planet now, look at that. A real red planet. So, let's keep going. Let's see what else we get. Maybe the sun will collide with it at some point, maybe. So, we're going at the fastest we can run it now. Actually, no, we can go a little faster. So, well, here we go. The sun's coming in for another round. So, looks like Venus's orbit has just been stretched out there, as you can see. So it looks like Venus may be ejected here. So yeah, it's gone. Venus is gone. The sun. So the sun's just a rogue now. It's just by itself. So Eris has basically stolen the solar system off the sun because it looks like most of them are orbiting Eris now, as we can see here. But some of them may be around the sun. Planet 9 probably is around Eris. Sedna's definitely around Eris because it doesn't even cross the sun. So the poor old sun has just been made obsolete by this new star. So look at that. Mars is still just glowing hot, which isn't very good. But yeah, there we go, guys. So different solution for a change. The sun has actually been beaten without a supernova being cool. So we'll keep going, obviously, just to see if anything else unfolds. So we'll keep running as fast as we can go. So we're travelling at about 2 years a second here because we can't go any faster. But yeah, Pluto's been ejected. All of these guys have. Well, the sun's coming back in there. Oh my god, the sun really, when the sun comes in, it really messes with the orbits, so that's pretty crazy. But yeah, let's just delete all these objects which are escaping the system, so it will make the simulation less laggy. So let's delete you, delete you, delete you, delete you, delete you. Hygeia got really far away, damn. Alright, anyways, let's go back into the system here. Wait, where's it? System! Wait, where are you? Where is it at? Oh, we just lost it. Let's lock onto it. Okay, there we go. So, how is Venus still surviving this? Venus is only at 100 degrees now, so it's a little colder now. But let's see what's going on in the main area here. So, poor old Mars, man. It's just stuck in the centre. Oh, that's not good. Yeah, poor Mars. Rip Mars. Yeah, rest in peace, Mars. You're done. Never going to be cold again, that's for sure. Oh, Saturn's coming back up for another spin. There it is. Zooming in and out again. Yeah, so Mars looks like the only planet which is really glowing hot now. So, all the other planets are relatively safe, but yeah, Mars is doing it. Oh, the sun's just changed all the orbits again. Sedna looks like it's been ejected. Planet 9 is still hanging on there, but let's keep going. The poor old Sedna looks like it's gone, actually. Oh no. So Sedna came in, it looks like it's just been thrown out. I know Sedna is surviving, it's got a very strange orbit again. Charlico's got a very crazy orbit there, you just saw the orange one. But look at that, oh my gosh, look at this. Okay, we've got the sun as well, just chilling. But it looks like, we'll keep running this, but it looks like the sun is actually in the binary orbit of Eris perfectly. It's not gonna, the sun and Eris are never gonna collide now, but it looks like only the planets are really gonna get thrown out. So, to conclude, Eris into a star, if we turn Eris into a star with these statistics here, it makes a binary orbit with the sun, or it pulls the sun towards it, it steals a bunch of the planets, then it makes a binary system as you can see here. And then they live happily ever after, with poor old Mars being burnt to death in the inner solar system bit here. So, poor old Mars, man. Rip Mars. It's just permanently above 1,000 degrees. So that's the hottest planet in the solar system now. It's just a inferno here. Look at this. Just slow down. Oh my god. How's the North Pole still white with like snow and stuff? How's that work? Oh my god. That's gonna really kill some eyes if you're watching at night time. Sorry about that. Okay, there we go. The white's disappeared now. But yeah, there's Mars. Not doing good, so... Oh, the South Pole is still cold. Look, the ice bit. Anything on the North? No, the North's gone. Can you see it? Oh, no, they can. Look, there it is. The North and South Pole. I don't know why they're white, but that's that. It's just part of the texture of Mars. But there we go. That is it for this video, I think, because nothing else is really happening. As you can see here, like, we're going as fast as we can. So, that's that. So... The only things that happen from now is the planets will get ejected, because that's the only thing that could happen, since this is quite a very crazy orbit, as you can see. More have been thrown out, as you can see there, but yeah, that is that for this video. So hopefully you guys all enjoyed. Make sure if you did, leave that like, and subscribe for more helps on the journey to 1,300 subscribers, because that would be awesome. If you've got any ideas for another video, or if you want to choose what coloured solar system we do tomorrow, then just leave a comment, and yeah, that's that. So make sure you have a good day, and I'll see you in the next video. Goodbye. Or yeah, about double the size of what Earth is now here, so this is good, and let's keep going. I'm getting a lot bigger now, so now we're at the size of almost Planet 9 here, so this guy's getting pretty big here. So quick comparison with the planets here, this guy is just a little smaller than Planet 9 now, so a lot larger than Earth. So it's giant rocky planet now, no longer a dwarf planet. So let's keep going, let's make it even bigger. So let's get going. Alright, come on, let's go. 60 Earths is really increasing fast now, so let's keep going. Let's see how what it is in Jupiter's here. So there we go, it's half the mass of Jupiter, and it's still going now. Now we've got to the mass of 1. Hello everyone, and welcome back to another Universe Sandbox video, and today we're actually going to turn in Eris into a star. So if you remember last episode we did Charlico, and you guys seem to have liked that. So yeah, someone said to do Eris, and I'm like, hang on, I've never done this one. I'm surprised I haven't, because this is like the second main dwarf planet after Pluto. So yeah, I'm pretty surprised I never picked up on doing this one. So yeah, we're going to be doing this today. But yeah, before we get started, guys, just many thanks as always. We're now at 1,220 subscribers as of making this. So yeah, let's keep up the good work, and let's see if we can keep going to 1,300 before the end of the month, because that'd be cool. But anyways, let's get into this. So what I'm going to want to do here on Jupiter now, and then getting bigger and bigger. So now we're exceeding the size of Jupiter here. So this is a pretty large orbit now. Let's keep going. Let's make it the size of like... what stars should we base it off today? So we're not going to base it off one of the hyperstars. Let's base it off maybe Spicer. Oh, let's use this one, this Archinar, because I have never ever used this star, I don't think, in a simulation. So let's get some use of that. So we need to make this thing the mass of 6 suns. So let's keep going. So let's do this, and let's go. So the mass of 6 suns. So now it's a gas giant, as you can see. It's just got so big, it's now just gas, even though. Okay, so let's do it a different way for a change. Instead of just colliding it with stuff, let's just manually make it bigger, because we don't really do this much. So let's just make it bigger. So now Eris is pretty much, yeah, this is large enough to be a planet now. So let's keep going. So we're going to get a nice large Eris. So yeah, this is my custom one as well. So if you want a good look at it, I made it nice and white, so it's like a frozen sort of look. I like it. So yeah, there we go. Anyways, let's speed this up, and let's keep going. So yeah, it's quite a unique way of doing it, because I've not done it like this in a while. So let's go. So yeah, anyways, looking good. So, and also guys, coloured solar system episode will probably be coming out tomorrow. So yeah, tell me what colour should I do. So we've got 4 left now, I think. So it's brown, white, grey, and I think they'll ground. Is it grey, white, brown? And is that it, or is there more colours? I think it's just those two ones, and then pink as well. Yeah, pink. So yeah, pink, white, brown, or grey. Which colour should I do? And if you've got any more colours, feel free to comment them down as well, because that's cool. Because yeah, if you want the series to keep going, I need more colours to do. So yeah, that's how. Yeah, but probably expect a coloured solar system episode tomorrow. So yeah, stay tuned for that and tell me what colour you want. Anyways, let's keep going here. So now with the size of